Hi everyone, my name is Amulya, mechanical second year regular. Today my topic is about construction and working principle of synchronous generator. Alternator is electrical machine that is also known as synchronous generator that converts mechanical energy into electrical energy. Alternator has two main parts, one is rotor and one is stator. Rotor is the rotating part and stator is the stationary part. Rotor has field winding and stator has armature winding. This rotor consists of two types, salient pole rotor and cylindrical rotor. The first main part is stator. This is the front face of an alternator. The basement provides mechanical support to the alternator. Frame is provided at the outer portion of alternator that protects the elements of alternator and gives the cooling effect. In case of small size of alternators, cast iron is used. In case of big size alternators, welded steel is used. And it is the stator core that is made up of laminated silicon steel that have high permeability and it provides low reluctance path. The meaning of lamination is stator core is arrangement of various thin sheets with provided lamination to reduce eddy current losses. At the inner portion of alternator, slots are provided where three-phase winding remain placed in star connection. When coils are added in series, then it is known as a winding that is placed in the provided slots. The second main part is rotor. There are two types of rotors used in alternator, that is salient pole rotor and cylindrical rotor. Salient pole rotor consists with salient poles, means poles which remain projected outward. It has non-uniform gap. Steel spider is used to attach the projected poles together. Concentrated type winding is used in salient pole rotor because it has non-uniform gap. We provide lamination in rotor core to reduce eddy current loss and it made up of high permeability material. Damper bars provided at the pole face of salient pole rotor that damp the oscillations due to non-uniform gap. Coming to the working principle of synchronous generator with salient pole rotor. DC excitation is given in field winding that placed on rotor using slip ring and brushes. Due to DC current, constant magnetic field produces on rotor pole and mechanical energy is given to rotor by external prime mover. By using steam turbine, we rotate the rotor and by coupling the shaft. And when the turbine rotates, then alternator rotates. Thus we give the mechanical power. As well as rotor constant pole begin to rotate and creates rotating magnetic field. And this rotating magnetic field cuts the armature conductor placed in armature slots. Due to relative motion between armature winding and rotating magnetic field, EMF induces. As a result, EMF induces in armature conductor and AC current circulates when its circuit will completed with load. Direction of induced current in armature winding is determined by Fleming right hand rule. Thus an alternator operates and generates AC current. The induced EMF in armature winding is directly proportional to the speed of the rotor RPM coupled with the prime mover. Then the equation is given as Ns is equals to 120 F by P. Ns is the synchronous speed, F is the frequency, P is the number of poles. We consider frequency is 50 Hz and poles are 4, 120 into 50 by 4. Then the speed is given as 1500 RPM. It consists of three types of excitation system: DC excitation system, AC excitation system and brushless excitation system. In this brushless excitation system, DC current is given in field winding of alternator without slip rings and brushes. Advantages of this alternator is armature of alternator remains stationary, so the output is taken directly from its terminal without brushes and slip rings. It has no risk of spark, wear and tear and requires less maintenance. Alternator has no brush voltage drop. Alternator has high efficiency compared to DC generator.